Welcome to The Explainer. Look, if you've ever tried to get an AI to do something even slightly complicated, you know that feeling, right? You craft this perfect prompt, you hit enter, and it just doesn't work. Today, we're going to talk about what comes next.
So here's the plan. We'll start by looking at why prompt engineering is hitting its limits. Then we'll get into its successor, context engineering. We're going to break down the 4 main tools engineers use, look at the very real dangers of getting this stuff wrong, and finally, explore what it all means for where AI is headed. Okay, let's get into it.
All right, let's start on familiar ground, prompt engineering. It's the skill we've all been trying to master, right? How to ask the AI for what we want in just the right way. But here's the thing. The game is already way past that.
On one hand, you have prompt engineering. That's all about the art of the perfect one-shot question. You ask a great question, you get a great answer. Simple. But context engineering, that's a whole different ballgame. It's not about the question anymore. It's about designing the AI's entire workspace, its whole information environment, so it can handle huge, multi-step jobs.
And this is exactly where the old way hits a brick wall. As soon as we start building truly sophisticated AI agents, ones that can do research or code for us, that single prompt idea just falls apart. In fact, sometimes a super long, detailed prompt just makes things worse because it just confuses the model. It's all instruction with no bigger picture.
It's because of this exact problem, this limitation, that a brand new and incredibly important discipline has emerged. To really get your head around context engineering, we first have to talk about the fundamental problem that every single large language model is facing. What is their single biggest constraint?
And this right here just perfectly sums it up. The AI expert Andrej Karpathy gave us his brilliant analogy. Think of the large language model, the LLM, as a crazy powerful computer processor, a CPU. But that super fast CPU has a tiny amount of working memory, its RAM. And that limited workspace is what we call the context window.
So, this is where context engineering comes charging in. It's the art and science of managing that very limited RAM. It's all about dynamically packing that context window with the right information, in the right format, at exactly the right time. You're not just asking a question anymore. You're actively programming the model's focus, moment by moment.
So, how in the world do developers actually do this? How do they manage that precious, limited RAM to build these powerful AI systems? Well, they have a core set of tools they use.
This chart breaks down the 4 main strategies. First up, you've got writing. Think of this like giving the AI a scratch pad or a little notebook. It can jot things down so it doesn't have to keep everything in its head. Second is selecting, and this one is absolutely crucial. Instead of a messy workspace, the AI only pulls in the most relevant data for the job it's doing right now. A huge technique here is RAG, which basically fetches facts from a big knowledge base on the fly. Third, we have compressing. To save that precious space, the AI can summarize long documents or just trim away details that don't matter. And finally, isolating. For a really big job, you can split it into smaller pieces and give each piece its own clean, separate workspace. That way, they don't get in each other's way.
Mastering this toolkit, writing, selecting, compressing, and isolating, that's what makes it possible for developers to build those amazing AI agents we're talking about. The ones that can actually handle long, complicated assignments without getting lost or confused.
But, this is a really delicate balancing act, and when this complex management of the AI's RAM goes wrong, the results can be, well, pretty catastrophic.
And I'm not kidding. When an engineer gets this wrong, it's not some small bug. Mismanaging the context window doesn't just make an AI a little bit slow. It can cause the entire system to break down in predictable and honestly disastrous ways.
These failures are so common they actually have names. You've got context poisoning. That's where one tiny error or hallucination gets into the AI's memory and it just keeps repeating it, derailing the whole mission. There's context distraction, where the AI gets fixated on one small, irrelevant detail in a long document and completely forgets what it was supposed to be doing. Then there's context confusion, when AI has too many tools and it gets confused and picks the wrong one for the job. And finally, context clash, where the AI gets contradictory instructions and it basically just shorts out.
So, okay, why does any of this actually matter to you? Well, if you're a developer, this is the skill now. This is the shift from being a prompt writer to being a system architect. But for the rest of us, it gives us a super powerful way to think.
When you give an AI good, relevant documents to work with, you're not just giving it data. You're doing your own little version of context engineering. And trust me, you'll get way better results because of it.
All right, let's pull all these ideas together and look at a real-world example of how this stuff is already shaping the future of AI. So picture an AI research assistant. You give it a really complex research question. Instead of just diving in, it uses these techniques. First, it deconstructs your request into, say, 10 smaller, manageable subtasks. Then, it prioritizes them, figuring out what to do first. It executes each one, maybe using a web search tool, and then, at the very end, it synthesizes everything it found into one clear, concise summary. And the key here is that this whole sophisticated process isn't driven by one perfect prompt. It's a living, breathing, multi-step workflow that is made possible only by the continuous, intelligent management of the AI's context.
This is exactly why context engineering is so quickly becoming the #1 most critical skill for AI engineers. It's already overtaking basic prompting as the discipline that really defines what advanced AI development looks like. At the end of the day, what we're really seeing here is a fundamental shift. We're moving away from just giving AI a list of instructions, and we're moving toward designing the very reality that it operates in.
Which leaves us with a final and pretty fascinating question to think about. As we move deeper into this new era, are we no longer just prompting an AI? Are we, in a very real sense, starting to program its reality? Thanks for joining us for this explainer.